Okay, now hydrolysis reactions are quite good in that once you know how to do one, you really in many respects know how to do all of them. So they all follow a similar pattern. Now just a little bit of advice to start with. Usually the acid you're using is a dilute, either hydrochloric acid or sulfuric acid, either's acceptable. And also usually for base hydrolysis using dilute sodium hydroxide. Okay, so basically these all follow the same premise where you've got either a I should have drawn this somewhere else, but I'll just draw it on a piece of paper. I'll just quickly put over the top here, where you've got a ester link or a amide link. You're looking for this carbonyl group, and you're going to be doing basically a split just next to it. Now, you just need to make sure on the right side. Now there'll be an O on one side, and if that's the case, then you've got an ester, and you do the split there. And there's an N on. If there's an N next door to it, then it's an amide, and you do the split there. Okay. Right. So in this case, when we look at this, we see that we've got an amide link there. And under acid conditions, you're going to get two products. You're going to get one from this side, and you're going to get one from that side. So effectively, what's happening is in a condensation reaction, an H2O was removed, or an HCl was removed. In this case, you're putting an H2O back in. You're putting an OH and an H. And the OH usually goes on that side where the C double bond O is, and the H will then go to that. So really you're just doing a little bit of copying. So if I was to copy out this on this side for the acid side, I do 3 carbons in a row with double bond O, and I put the OH back in at the moment. And we have the NH2, and we put another, we have that being NH3 if we put another H back in. Now this is under acid conditions, and under acid conditions this acid it's going to stay an acid. But this is a base, and it will actually end up becoming protonated because a base will accept a proton. So instead of being NH3, it will in fact become NH4+. Okay? And that's a similar thing you'll see all through this. You've got to consider what happens under acid and what happens under base conditions. Now the same thing happens here. You're going to get this split that happens, so I'm just really copying this out again. Now, I'll just copy there. I'm going to leave that for now, and I'll make that NH3. Now under base conditions, now all I've done is put the H back on the N, so it's got 3 things. It's NH3 there. This is a basic chemical, ammonia, so it'll stay a base. Now if I was to write OH, that's an acid, and under base conditions the acid will react with a base. So instead of being OH, it's going to be O-, and it's going to be Na+. Okay? You can just write that as Kuna, I guess. But at the moment I tend to do it with a minus and with the plus sign next to it. Now if we go down, we see another case of hydrolysis. And again, we're looking for the C double bond O, we see that, and we put a little break between this and the O. And under acid, then we're going to draw out both of these molecules under this one, and we're going to draw out both of them under this one. Under acid conditions, we'll have, I'm just copying that out, 3, and then we're going to put remember we're putting an OH and an H back in. So previously under condensation we were taking them out, now we're putting them back in. And under acid conditions this stays an acid. Now alcohols are also neutral, so they don't actually do anything under base conditions. So once you put the H back onto this O, it really doesn't do anything, and so that's the OH there that I've kind of put it back on. So, oops, I don't know if you can see that. So now I've just moved that up. So this is the alcohol that I've been drawing. So the alcohol is neutral, so it does nothing, and the acid under acid conditions does nothing. Now, if I basically copy that out on the other side, and this time, this acid, if it reforms under base hydrolysis, is going to react immediately, and it's going to basically form this, so the conjugate, okay? And we also have the alcohol. The alcohols always stay alcohols when they reform. So They don't react, they're not acidic, they're not basic. Okay? So a lot of the questions in NCEA may have you just doing just acid hydrolysis, in which case I just expect both of those products. Some will want base hydrolysis, in which case you'll have those products, and some will want you to compare and contrast. Now if that's the case, you'll be talking about how they both have the alcohols reforming, and you talk about the difference between the product of acid hydrolysis for the acid, which basically stays the acid, and how you get the conjugate and base of that acid, because it's under base conditions the acid will react to form that. Okay, so that's hydrolysis, and really this pattern just stays the same all the way through. So for instance, we have here, we look at this, we think, well, that's really a big kind of chemical, and it's a triglyceride. These always look a bit scary, but they're basically the same. So we look for the C double bond O, and we see an O next door. So we're going to split there, we're going to split there, we're going to split there. So I'm going to draw this in the middle, which is glycerol, so you should know its name. Okay, because under triglycerides, that is the only alcohol that we ever talk about. So again, we're basically putting OH back here, and we're putting an H back in here. So we're putting 3 waters back in every time, right? So under acid hydrolysis, we'll get the alcohol reforming, and under base hydrolysis, we'll get the alcohol reforming. Now, I'm just going to draw out one of these, and they're all the same. Now, if these were different, and I would draw them all out differently. Now under base hydrolysis, we're going to, it won't reform the alcohol, the acid. You'll get O minus and Na plus. Okay, now that has a special name, it's called soap, but we're also going to get 3 of these forming as well, because there's 3 here. Okay, so that's under base hydrolysis, we would get this and we would get this. Under acid hydrolysis, it's really very similar. We get, I'll just draw out one here, C double bond O. We will get the OH, because under acid conditions the acid doesn't react to do anything unusual. CH2, put 9, and then CH3. Now that's going to be times by 3. There'll be 3 of those. So what they have in common is they both form the glycerol, but they again show that same pattern of under acid conditions the acid won't react, it'll just stay the acid, but under base conditions an acid can't reform, instead we get the conjugate base that forms. Okay, now if we go down, again the same kind of pattern we're looking for under hydrolysis. We're looking for the C double bond O, and we're looking for an N or an O next to it, and in this case it's an N, so we draw a line down it, then we come along, we're looking, we see another one, and then we have a look and we see another one. Now we should only have to do 3 of those, and this is going to be 1 unit, and this is going to be 1 unit. Now if these units looked pretty much exactly the same, it might tell us that there was only 1 monomer here. But this is clearly different from this. So if I redraw this, and so again we're going to be putting OH back in, and we're going to be putting H back in. It's the same pattern that we see all the time. And we're going to have that going in, H going in, C double bond O, and we'll have OH. So putting OH back in. Sorry, you can't see that. So that's basically this copied out here and put here. Now under base hydrolysis, and also I'm going to just copy this one out and put it underneath it, or here, so you can see it there. So it's going to be NH. I'm going to put another H in it, and then come along to C, CH3, CH3. And then N, I'll just say NH2 like that without drawing it with the little showing the bonds so clearly. So under base hydrolysis, under acid hydrolysis, the acid will stay the acid, but this is basic, these are amines. So they will actually receive a proton and become NH3 plus, and this will become, I'll show it this way, NH3 plus as well. Okay, so under base hydrolysis, we're going to get a similar thing to what we've had previously. So instead of having an OH here, we'll have an O minus and an Na plus. Then we'll go across to here and we'll have this, and we'll have that with the O minus and the Na plus. And here we're going to have, instead of having, we're just going to have NH2. Okay, except I think I might have, how many carbons have I put in there? There's just one. Okay, so that's supposed to be a N there. Oops. And that's just going to be NH2. So we just have NH2, NH2, CH3, CH3. So all we've done is we've basically put an H there and an H there, and that's that one there, even though it's a little bit messily drawn. Okay. Now once again we're going to see the same pattern. This is just another polymer, and we're just looking for where it's kind of joined. So we've got the C double bond O and single bond to the O, and we just go along and we just do some splits. 3 lines is always sufficient usually to do that. So if we then just basically, I'm just copying out this one, and we're going to have the OH going back in and the H going back in on the other side. Okay, so water's basically been put back in. So we have CH3 up there, and then we have OH, and remembering that alcohols, that when they reform in these reactions, they're always going to be unaffected by the acid or base condition, so there's nothing unusual. Now we've got the acid side, and if we're reforming an acid, obviously an acid doesn't react in acid conditions, so it just stays how it is. So we get the C double bond O, OH. So that's if we just asked for acid hydrolysis, that's all we draw. Under base hydrolysis, we'll be drawing a very similar thing, because it's not that different, and the alcohol stays basically an alcohol, so we're just going to draw that out, and have the OH and have the OH. So those two are exactly the same if you're doing a compare and contrast. And then we have the acid, which, because it's under base conditions, the acid can't really exist how it is, so we get the conjugate base, which would be O minus, and assuming it's sodium hydroxide, it would be O minus Na plus, and we have CH3 there, H there, and, oh no, sorry, I'm drawing out the wrong one, that's just got 2 H's, so that should just be an H there. It's a bit more messy there, and an H there. I'm doing this one here, C single, so, and that's O minus Na plus. So anyway, just poor copying skills on my part there, but that's Na plus O minus Na plus, and it's really just copying this back out and putting that back in, and having O minus Na plus in this case, O minus Na plus in that case. That's all it is. Now this is very similar. This is a say a dipeptide, so we're looking for this. We're going to split it there. We've got the peptide link, so if we do that under acid hydrolysis, we'll get this. Just copy out the bit to the side, the H, NH2, and C, CH3, and OH. Now that would be, under acid conditions, this will stay. This is basically an acid, so this will stay fine, but this is the base part, so it'll get protonated, and that becomes NH3+. And then for this one, we get a similar thing. We'd have, for instance, we had the OH going back in there, and the H going back in there, the same old kind of process. So we'd have NH2 normally, but because it's under acid conditions, it's going to become NH3+, and it's still going to be, oops, I should have had an H in there, shouldn't I? So it's going to go to the C, we've got a single bond H, and OH. So that's under acid conditions. Under base conditions, we would have, just draw these out first, CH3. So we'd have something like that, and next to it would have NCH, H, NH2. I'll just talk about this in a second where I've kind of got this C single. Okay, all I've done at the moment is copy this one out down here, put an H back on there, and and the OH was already there from there. And all I've done with this one is put it here, and I've left, that's like, this is the NH2 here, is this one here, and that's at C, CH3H, and C double bond O, OH. Now under base conditions, this group here is basic, so it's not going to do anything, but this is an acid group, so it'll become O minus Na plus, it'll become the conjugate, O minus Na plus. Okay, so that's just another example of acid-base hydrolysis. Notice the pattern that happens. Alright, and I've got a feeling that that is at